Okay, so next we'll take a look at a composition of reflections or reflecting over two lines. So reflecting over two lines could be the same as a single transformation. Okay, for example, on theorem 4.2, make sure you're putting this into your notebook, reflection in parallel lines. So if you're reflecting, whether it's a segment, it could be a polygon as well, but if you're reflecting over two parallel lines, in this case, lines K and M, so you're reflecting this segment AB once over line K, and then reflecting the image AB over line M. If you compare segment AB to A double prime, B double prime, you could notice that you could just translate segment AB to end up with A double prime, B double prime. So that's basically what theorem 4.2 states. If you're reflecting over two parallel lines, in this case, again, lines K and M, the reflection is the same as a translation. Okay, and then they use the A double prime is the image of A. But it's also true that A double prime, A, that segment is perpendicular to both of the parallel lines. And then A to A double prime, that length right there. So this length, which is number 2 right here, is what they're talking about, is the same as twice the length of the distance between the two parallel lines. So the main concept of theorem 4.2, there's actually two main concepts. Reflecting over two parallel lines has to be that the lines are parallel, as you'll see in the next theorem. But that's the same as a translation, and then the distance between the original or the pre-image and then the second reflection, that distance is the same as twice the distance as the distance between the two parallel lines. And then theorem 4.3 states if you're reflecting over two non-parallel lines, if they're non-parallel, then they would have to be intersecting. So these two lines, K and M, are intersecting specifically at this point, P here. So here's the pre-image, AB, that segment. Again, it could be a polygon as well. You're first reflecting over line K. You end up with A prime, B prime. And then you're reflecting over line M. And then you end up with A double prime, B double prime. If you're comparing A double prime, B double prime to AB, the pre-image, that's the same as a rotation. Again, make sure you're writing down theorem 4.3, reflecting in the intersecting lines theorem. So kind of what I just went over, K and M intersect that point P. The reflection first in line K, then in line M is the same as a rotation about point P. And we'll talk about the angle of rotation as well. So the angle of rotation from A, B to A double prime, B double prime is twice the angle between the two intersecting lines. The angle of rotation is 2x. So the angle varies. Let's just say this angle between the two intersecting lines is 60 degrees. Then the angle of rotation from AB to A double prime, B double prime would be twice that, or this angle of rotation right here is twice 60 degrees is 120 degrees. So that's what the 2x compared to x is. It's not always going to be 60 degrees. Say it was 45 degrees, which is the angle between the two intersecting lines. Then the angle of rotation about the point of intersection, in this case point P, would be twice that, or 90 degrees.